Hey guys, welcome to the week 4 ALU demo. So the ALU is our arithmetic logic unit, and it's responsible for doing addition and subtraction of two numbers. So here's our board for the ALU. So you can see with these yellow wires, it's connected to this board right here, which is the registers. This is the B register on the left, and in the middle is the A register. So these are the two that we're going to be working with. Additionally, we've got it hooked up to the testing board right here, which the green lets us see the outputs from the ALU, and then the blue lets us input values into the registers, depending on which one we select. So I think the best way to do this would just be to do some example calculations. So right now, let's add like 4 and 7 or something for an example. So I can go to these switches here and do the one that corresponds to 4. So, these are bits. This is the 1-bit, the 2-bit, the 4-bit, the 8-bit, 16-bit, 32-bit, 64-bit, 128-bit, etc. So what we've just done is flicked the 4-bit up, so 4 is being stored in here right now. And then, so I can control this with... Okay, and then if we put the load on for the other one, so what I'm doing here is I'm manipulating the control signals for whether we want to load the data from these switches onto the registers or not. So connected to the minus means that we want to load it, and connected to the plus means we don't want to load it. So that was 4, and now we'll put in 7 to the other one. Okay, and so right here is the same, so 1-bit, 2-bit, 4-bit, 8-bit, etc. So right now the number that we see on here is 8, 2, and 1. So if we add these together, we do get 11, and the original addition was 4 plus 7, so 11 is what we expect. So if we now try something a little bit more complex, like 100 plus 35 or something, then, so 100 consists of, the binary representation is 64, so that's this bit here, 2 to the 6, 32, 2 to the 5, and 4, which is 2 to the 2. So you can see I have these 3 bits flicked up here right now, and so it's being loaded into one of the registers. And then if I load 35 onto another register, so we have to add 35 in here. 35 is 32, which is this one. Oops, yeah, okay. This guy's 32, and then plus 3, so plus 1, plus 2. So this guy's 35. And then the number that we expect is 100 plus 35 is 135. Let's see if we do have that here. This guy is 128, plus 4 to 1 is 7. So 128 plus 7 is indeed 135, as we expect. So looks like the ALU is fairly capable of doing addition properly. We'll see how it does for subtraction. So, okay. So if we just try something pretty simple right now, and we'll also make use of negative numbers now too. So I'm going to put in 2 into the A register. So here's 2. And then I'm going to load in 7 into the B register. So when I subtract, it's going to be 2 minus 7. And then we'll see what sort of response we get. So, okay, and then I'm going to put 7, these 3 bits. Okay, and I have to change the flag here to subtraction. Okay, so we've got like a lot of lights lighting up here. So what does this mean? Based on the 2's complement negative representation that we have, this is actually negative 128. So if we try to figure out what number this is, we don't actually have to add it. We'll just use our conversion routine. So if we flip all these guys to 0, and then flip all the 1s to 0s and 0s to 1s, we'll get 0, 0, 0, 0, 0, 1, 0, 0. And then we add 1, we get 1, 0, 1. So basically, this number here is negative 101. 101 is 5, and so the number we have here is negative 5. And, well, the operation we just did was 2 minus 7, so we expected negative 5, and, here we go. This is negative 5. And then if we're going to try something a little bit more complex, we're going to do 118 minus 56. Okay, so let's see if I can compute this. So I'm currently loading in the B register right now, so I want to put in 56. 56 consists of 32, 16, so that's 48. And then we want 8 more, right? So then we'll get these 3. Yeah, so this is 56 here. And then if we load in A, I hope I don't mess anything up, for 118, then we want 118 is 64 plus 32, which is 16, plus, which one is this? 16, right? And then that's, so what's there? And then let's see, if we add in, I think this should be it. So this is 64 plus 32 plus 16. So 96, 112. And then if we add in again 4, we get 116, and then a 2 is 118. Okay, yeah, so this is 118. So what we've just done is loaded 118 onto here, and we've loaded 56 onto here. And then if we check the subtraction, then we get this number here. So 118 minus 56, we should expect 62. So let's see if this is 62. 32, 16, that's 48, plus 8, 56, plus 4, which is 60, and then plus 2, which is 62. Okay, so yeah. And, you know, there we have it. So that's 116 minus 56, and we get 62 on here. So basically, we just run through a bunch of different operations here, and, you know, the ALU is capable of doing all of these. So what we'll be doing later in the project is using this ALU to do the operations that we need our CPU to do.